Hi, this is Gabriel. Welcome to the third part of the Robot Components Beginner series. In this video, we'll have a look on how to set up a robot. As mentioned in the last part, we can define a robot by using components from the definition category. Throughout this course, we'll most of the time simply use one of the robot preset components. For now, I'll pick the IRB 1205 component and place it on the Grasshopper canvas. As you can see, we will immediately receive a preview of the robot geometry inside the Rhino viewport. The robot preset component comes with a total of 3 inputs. All of them should match up with the actual robot configuration of the IBB controller. The first parameter defines the position plane of our robot and will take in a regular Grasshopper plane. By default, it will use a XY plane, which is placed at the world's origin. The second parameter gives us the opportunity to add a custom robot tool to our robot. We'll explore in further videos how to set up our own robot tool from scratch. By default, Robot Components is using a placeholder tool where the tool plane equals the attachment plane of the robot. For now, let's move on to the third input, which lets the user define a list of external axes for the robot. Currently, Robot Components supports the use of external linear and external rotational axes. However, since this is a fairly advanced topic, we won't get into more detail here. Let us continue by using the deconstruct robot component to get an overview of all the hidden robot parameters we can't see in the preset component. I will also turn off the preview of the IRB 1205 component for now. If you have already worked with ABB robots inside other software, the list of outputs should be quite familiar. The first output shows the name of our robot. The second output will get us a list of all the meshes our robot geometry is composed of. Typically, this list is made up of a mesh for the base and one for each link. The third output contains a list of all the robot axis planes. In this case, we get a typical set of 6 axes for our robot. We can use the plane visualizer component from the utilities section of RC to preview them in Rhino. Each robot axis is now visualized by a set of 3 vectors. The blue one indicates the z-axis of each plane, which is also its facing direction, while the red and green one represent the x and y-axis. Let's move on to the next output. This defines the actual axis limits. We can see that they are defined in degrees by a list of 6 domains, 1 for each axis. The robot is only able to rotate its axis within those bonds. Since we already discussed the other outputs in the IRB 1205 component, we'll skip them except for the mounting frame. This defines the plane the robot tool will be mounted to on the robot. We can plug the mounting frame output into our plane visualizer to get a preview in Rhino. In case of the IRB 1205, the position of the mounting frame is equal to the position of the 6th robot axis. Now that we have looked at all the different outputs, let's see how we can create a custom robot definition. We'll need the robot component for that, which is also found in the definition category. As you can see, its input parameters match the output parameters of the deconstruct robot component. We can simply connect all its outputs to the robot component inputs to create a new robot definition. Of course, we could also create all of the input parameters from scratch, or simply change some of the data to adapt the robot to our needs. However, for now, I'll delete all of the components since we don't really need to create a custom robot definition at this point. That's it for now, and I hope to see you in the next video where we'll explore how to visualize robot poses inside of Rhino by making use of the forward and inverse kinematics components.